Today's episode is sponsored by Swoosh Technologies, focused on improving innovation and product design quality. Visit them at swooshtech.com.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello, and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. I'm Amy Bryson, contributing lead editor of Smart Manufacturing Magazine. Today, we'll be talking about how adaptive control and monitoring, or ACM, can revolutionize your manufacturing processes. My guest today is John Vincent, Technical Director and CAM Application Engineer at Swoosh Technologies and Solutions. That is a fun company to say. A company that provides engineering solutions and services tailored to small and medium-sized, discrete manufacturers, which I know makes up a good portion of our audience. I want to thank you for joining us, John, and welcome to the show.
Hi, Amy. Thanks for having me here today with you.
Well, you're welcome. And before we jump into our discussion, can you give our listeners a bit of background about you and the work you and your team at Swoosh Technologies are doing?
Absolutely. So the team here at Swoosh, on the technical side of our business, we're here to support and enable our customers to best utilize the Siemens platform across the scope of all the tools that we offer in design, data management, and manufacturing, which is kind of why we're here today. And some of my past experiences really start to cover all aspects of manufacturing, chip manufacturing. And that's one of the things that I really love about this position is that I get to stay exposed to a lot of different customers' environments and applications.
So let's start out with some basics. What exactly is adaptive control and monitoring, and why is it important?
So there's really kind of a whole variety of subset of tools inside of adaptive control and monitoring that allow for improving processes. And we can improve processes through a number of ways here. We're able to have more stable cutting performances. We can decrease cycle time of our operations. We can eliminate tool breakage and improve the quality of our finished goods by running the ACM modules on a Siemens control.
And, a lot of our listeners are focused on kind of modernizing their shop floors and pursuing their own smart manufacturing journeys. So if they're looking to leverage ACM, do they need a specific controller?
Not necessarily. So ACM is very easily applied to a Siemens controller. Really, when you have a Siemens control, if it's a Siemens Cinemeric 840D control or their latest generation of control, which is the Cinemeric 1, all the hardware is already on the machine, the edge devices, the sensors, things like that. So it becomes just a software option to enable access to the various tools that we have. Whereas if you have a third-party control on your machine tool, we can still use these solutions. However, it's a little bit more effort to implement them on a given machine tool, in that we have to maybe add a edge device, maybe even adding some additional sensors to the machine, depending upon what your machine is currently equipped with. And really, if you're at the stage of wanting to learn how do we really apply this to your particular machines, that's a perfect time to reach out to a supplier of these Machinum portfolio products. And we do some analysis on your current equipment to make sure that everything's a good fit and to make sure you have an understanding of what it's really going to take to get you up and running with these tools.
So what is typically the light bulb moment where someone, would spur them to consider, ACM?
So typically the kind of the hook is faster material removal. That's kind of the thing that people really like to talk about. It makes for very simple ROI calculations to justify investing in some of these tools and efforts. And so that is far and away kind of the easiest selling point or reason for people to kind of hop on this bandwagon. So this is really part of the optimizing of my machining is what we call it, where we're really analyzing the cutter paths. We kind of teach the machine based on some known parameters. And really the teaching is as simple as just running a part. And the control will record the loads of various axes and the spindle. And when we get in and actually run and apply what we've learned, and again, this is kind of just flipping the switch on the control, say, hey, let's really apply ACM. The control will change feed rates as necessary based upon the actual real-time data that the control is receiving from the machine to either increase feed rates, decrease feed rates, and these conditions are changing based on maybe material conditions that you might have of your blank stock, maybe worn tooling, maybe parts loaded a little bit differently for piece to piece there. So that it handles a lot of different scenarios, and that's really kind of what oftentimes delivers this reduction in cycle time.
You know, a lot of conversation around how optimization is difficult or challenging, especially for smaller manufacturers. It doesn't sound like ACM is that difficult to implement and, get into action right away. Can you walk us through, a scenario?
Yeah, so really the first thing that we say to get going on this, again, let's take the scenario that we have a Siemens control on our machine. We can come in and test it out on your machine. We can give you some temp licenses to go ahead and turn these functionalities on and do a little bit of training on how do we go ahead and kind of train the machine for a specific part you're running or some kind of a specific process to really learn what is acceptable limits. We apply some additional limits. How much do we want to allow the machine to speed up or slow down based upon the real-time data? And in reality, we can come on site and do this in a day's time to kind of as a prove out. So while there's a lot that's going on behind it, the rollout is really not that complicated to get started in running ACM.
I think it's really important message for our listeners to understand that these solutions may sound complex and complicated, but really in practice, it is extremely eye-opening to hear folks like you talk about how it really isn't. Technology right now has become very user-friendly, and the rollout can be almost seamless, and the returns and the benefits can happen immediately. I mean, you mentioned faster material removal. What are some of the other benefits that manufacturers can expect?
Yeah, the metal removal rates are, of course, kind of that hook that pulls people in. But in my opinion, that's really not the biggest benefit here. The biggest benefit, from my perspective, is process stability. So I come from a background of running production environments with unmanned operation, lights out operations for kind of high mix, low volume environments. So certainly not running, thousands of one part. We would have lot sizes typically of maybe 25, maybe 50. That's that would be a very large production order for us. So the process stability of being able to let machines run without active supervision, staff standing by the machine, is to me the big benefit here. And the fact that we can use kind of the tool monitoring application or aspects of ACM to really identify worn tools so we can change them out before the tools break, to make sure that we're adjusting for these real-time cutting conditions, keeps production going. And that's what I think is the most valuable on a day-to-day basis.
Well, yeah, that's all really good stuff for our listeners to hear. And let's switch gears just a little bit. I have heard of VNCK and its machining simulation. If a manufacturer already has a CAM system and they can do simulation, why would they need this?
So VNCK is a really great tool. And that VNCK stands for Virtual Numeric Control. And so we have really two different products, and it's really kind of split apart from the various control types. So we have the 840D, which is hugely popular in industry. There's many, many controllers out there. But now Siemens has come out with their new variant, the Cinemeric 1, kind of the latest, greatest here. And so really what we can do with this simulation is we're taking really the knowledge of the control, the actual operating system that is running on the control on your machine that's on the shop floor, and we are embedding that either inside of Siemens NX. That's the way that we typically implement these solutions is integrated through Siemens NX, or they could also be run on kind of training simulators, controlled simulators, if you're not running NX software. And so the running kind of that same software that the machine tool is actually running allows us to grab the archive files out of your machine. So that means that we're grabbing all of your machine's specific parameters and settings. So we're really going to the next step of a true digital twin. Typically, most CAM systems conduct simulation in one of two matters. One, the first way, and this is kind of historically the way more softwares work, is that we have a digital machine tool that we describe kind of the axes, how the machine can move. And then we drive that tool based upon just the internal tool paths. So not the actual code that the machine is running. So it's showing, here's what the machine likely will do. But it doesn't encapsulate things like tool changes, maybe probing, motion of steady rests or tail stocks or part transfers, all these kind of auxiliary functions that happen in our manufacturing process, but we're not really driving from toolpath operations, more from maybe post-processors or things of that nature. And that's where we're getting into kind of the second stage of simulation, where we're actually simulating based upon the same NC code that goes into the machine tool. So that's where we do start looking at conducting tool changes, maybe tool breakage checks, all these different scenarios. And VNCK kind of is the next stepping stone in that we're driving the logic based upon the actual control of the machine tool and not emulating those functionalities.
So it sounds like that VNCK is kind of the brains of the machine tool. Is that fair to say?
Yeah, absolutely. So it truly becomes a one-to-one digital twin, as opposed to more of an emulation, which is what typical G and M code simulation is. It's not the same one-to-one logic, but when we get into VNCK, it is. So what is being simulated on your PC is actually what's going to be run out on the machine tool. And this enables us to get to better planning tools. So cycle time, for example, we are able to capture the exact cycle times that a part is going to take, even when we start using advanced functions for limiting or adjusting feed rates based upon smoothing settings or prioritizing our strategies for various operations. Oftentimes we can balance between quality, speed, and accuracy. And by making those settings and running them through a VNCK simulation, we're simulating the exact motions that will occur on your machine tool.
Very cool. I mean, it's such a dynamic time for manufacturing, especially for small and mid-sized manufacturers. And I know you spent a lot of time working with them and talking to them and helping them, get smarter, make better decisions. What is it that you're most excited about in the year ahead as you continue to work with some of these smaller and mid-sized manufacturers and seeing what's actually possible?
So one trend that I see is just that even the smaller shops are really embracing a lot of the latest, greatest technologies. And I think that was not always the case. In my experience, we typically see new technologies embraced by larger companies, larger organizations, and then you kind of have the trickle-down effect that it gets into the medium-sized businesses, smaller businesses. And I think we're at that point with a lot of these chip manufacturing topics. So just being able to have access to more users that are getting excited about implementing some of these types of strategies, and not really relying on kind of the mindset that the way we always did things is the way we do things, and really venturing out and looking at the future of how they can still compete, being a small market business.
Yeah, and it's an interesting topic about how technology is helping to bridge even a collaboration gap as, maybe more experienced workers on the shop floor are, having to work with this next generation of workforce, and we're coming together to have that tribal knowledge with new technology that can kind of unleash the potential of really everything that's going on is such an interesting, it's an interesting time for manufacturing.
Yeah, the workforce topic is exciting and challenging, to say the least. But that's one of the great things about a lot of the technologies that we have, whether it's on the software side, in manufacturing, being able to kind of embed institutional knowledge of how, the best practices of producing parts or certain features. We're getting to a point where we can really embed that kind of knowledge into software. So, the newer employees, instead of having to spend, years and years working with more experienced employees, they're able to take advantage of those benefits that have been embedded in the software right away as they start in their careers. And we're starting to see the same thing. I can draw some analogies here with ACM. I think we all have spent some time in machine shops where you can sit there and talk with machinists that you might watch them and they put their hand on a machine tool because they want to feel little vibrations, things like that, or they're listening to the tone of how things are cutting, and maybe they're adjusting speeds and feeds based upon that input. And in reality, that's what ACM is doing, but it's doing it at a much faster rate, and it's doing it in a manner that is not static, that we need to tweak things for this one operation or that one operation. Based upon all this data that's coming back real time, it's making these adjustments on the fly.
Yeah, that's a really interesting point. So let's talk about what you guys have coming down the pipeline. Any places you're going to be? What should our listeners know about?
Absolutely. So Swoosh Technologies will be at IMTS this year. We'll have our booth there. I'll be there myself, as well as some of our sales staff and other technical people. Siemens will have their booth as well. We'll all be in the software section of IMTS.
For our listeners who are going to IMTS, make it a point to go visit them. It'll be really worth your time. Yeah,
we'll have some cool stuff there. We'll be able to have some good conversations and show some of these latest things. We'll be able to show, what does VNCK look like to an end user, speak to some of those benefits. I'm really looking forward to it for this year.
Wonderful. Anything else coming up that I know you guys do some local events?
Yes, we do these NX University events. So kind of showing the latest, greatest features in NX software. We cover manufacturing content, and we also cover design content in these events.
And if people want to check out where those local events are and when, should they go to your website, and where should they go?
Perfect. Yep, that's perfect. So swooshtech.com is our website. And in there, you'll be able to see all of our in-person events that we have planned for NX University, kind of around the Midwest and East Coast this year. We like to change up the locations of where we host these events to make sure we get coverage throughout the country. But these are always great events. We do full-day sessions in person, covering the latest what's new content, tips and tricks, things like that. We even have hands-on sessions that you can come in and get some exposure to the latest versions of the software and get some time to play, on a real machine here instead of watching videos, things of that nature.
Yeah, it's so those in-person events and that experiential learning and getting to dive into the technology and those use cases is so important. So you guys are doing a great job getting out there in communities. So for our listeners, make sure you go to the Swoosh website and check that out. And John Vincent, I want to thank you for taking time to join us and sharing your valuable insights with our listeners. And I also want to thank our listeners for tuning in. Make sure that you stay up to date about what's happening in advanced and smart manufacturing, and hear more podcasts by visiting us at advancedmanufacturing.org. Take care.